Hello students, in today's session of circular motion, very basics will be cleared through illustrations regarding AT, AR, A, angular acceleration, etc. etc. I would also like to say that detailed complete solution with additional information of these papers available on website statisticlearn.com. You can visit the site and have the solutions. इसी के साथ साथ मैं कहना चाहूंगा कि अगर अभी तक आपने माय यूट्यूब चैनल स्टैटिस्टिक्स सब्सक्राइब नहीं किया, प्लीज सब्सक्राइब इट एंड share with your colleagues and friends. Now let's start with the concept and questions. Concept regarding kinematics of circular motion. What is circular motion? Circular motion, one dimension, two dimension, three dimension mode. It is two dimensional motion. Or you can say motion in a plane. Motion in a plane. In circular motion, velocity continuously keeps on changing. Keeps on changing due to change in direction, even though speed is constant. The body is accelerated. Body is accelerated. Therefore, V equal to U plus AT, S equal to UT plus half AT square. Answer equation. Not applicable. Directly. Not applicable directly. Terms being used in circular motion: angular displacement, angular velocity, average angular velocity and angular velocity, angular acceleration, linear acceleration, which is part of centripetal or normal or acceleration, and you can say certain tangential acceleration and their relations between them. What is angular displacement? Angular displacement is a dimensionless quantity. Its SI unit is radians. 2 pi radian equal to 360 equal to 1 revolution. If angular displacement is very small, tending to 0, then it is a vector quantity. But if finite value is there, then it is a scalar quantity. If it is very small, tends to 0, vector quantity, but it is finite, then it is a scalar one. Angular velocity, average. Angular displacement divided by the total time taken. That is delta theta upon delta t. Because in this case we are taking the finite angular displacement, therefore it is a scalar one. It is a scalar one. Angular velocity. Angular velocity, in this case, this is the angular velocity. Means delta theta is very small. Delta t we are tending to 0. Then it is a vector quantity. This is vector quantity. It is a vector quantity. Direction of angular velocity is given by right hand thumb rule. What does it say? If we wrap the fingers of the right hand in the sense of revolution of the point P, sense of revolution is this one. The extended thumb will give the direction of angular velocity. V dot omega equal to 0, that is V perpendicular to omega always. Right? Then relation between linear speed and angular speed. In 10th standard, you have d theta equal to L by R. Angle subtended at the center, length of the arc divided by the radius. Say this is ds, then this will be d theta. ds equal to r d theta. ds by dt equal to r d theta by dt, that is V equal to R omega. This is the relation between linear speed and angular speed. What is angular acceleration? Angular acceleration denoted by alpha, rate of change of angular velocity, that is d square theta upon dt square. This is the both average and instantaneous angular acceleration axial vectors with dimension t minus 2 and unit is radian per second square. If alpha equal to 0, motion is said to be uniform circular motion, uniform circle motion, right? Now, regarding linear acceleration circle motion, as in circle motion, linear speed may or may not be constant, but direction of linear velocity continuously changing. Therefore, acceleration cannot be zero. Therefore, resolving this acceleration to components. One is tangential component AT and one is radial component. Radial component or normal component or centripetal acceleration all are same name, right? AR. It is responsible for change in the direction of velocity. In circle motion, there is always a centripetal acceleration is always considered variable because it changes in direction. Radial acceleration is given by v square by r, or you can say AR equal to omega square r square by r, that is r omega square in terms of angular velocity, right? Next, tangential acceleration. When a particle moves in a curve, the magnitude of velocity, that is speed of the particle, may change. Since the velocity changes its magnitude along the tangent to the path, the rate at which the magnitude of velocity changes along with the tangent is called the tangential acceleration. That is AT equal to dv by dt. V equal to r omega, that is d omega by dt, that is r alpha. In vector form, AT can be written as alpha cross r. This is the right. And then total acceleration is the vector sum of centripetal acceleration, tangential acceleration. That is vector sum. And magnitude is given by this, direction is given by this. This is the radial, this is the tangential, this is the total linear acceleration. Making it theta with the radius vector, then tan theta equal to AR by AT. Right? Now, let's start with the questions. Question is, a particle moves in a circle of radius 0.5 meter at a speed that uniformly increases. Find the angular acceleration of the particle if its speed changes uniformly from 2.0 meter per second to 4.0 meter per second in 4 seconds. What is our requirement? To find angular acceleration. Angular acceleration alpha. Angular acceleration alpha. Given a r equal to 0.5 meter, change of speed. The speed is 2 meter per second to 4.0 per second in 4 seconds. Therefore, tangential acceleration dv by dt equal to 4 minus 2 upon 4. That is 2 upon 4. That is 0.5 meter per second. Also, A equal to R alpha, alpha equal to A upon R. This comes out to be 0.5 divided by R is 0.5. That is 1 radian per second square. This is the angular acceleration. Right? Next question. Question is, speed of a particle in a circle of radius r equal to 2 meter. Where is the time as v equal to t square? Where t is in second, v is in meter second. Find the radial, tangential and net acceleration. Now, concept applicable in the solution. A radial, A tangential, A radial is v square by r. A tangential is dv by dt. And net acceleration is under root ar square plus at square. Now using these formulas, as we give to you v equal to t square, therefore dv by dt equal to, I think differentiating both sides with respect to t, 2t. Therefore, a tangential at t equal to 2 seconds will be equal to 2 into 2, 4 meter per second square. And a radial equal to v square by r. V is 4k square upon radius is given to you, that is 2. That is 4 into 4 into 2. That is 8 meter per second square. So net acceleration will be equal to under root 80 square plus ar square. That is 4k square plus 8k square. This comes out to be 16 plus 64. That is root 80. That is 4 root 5 meter per second square. This is the answer. Net acceleration, this is the answer. Tangential acceleration, this is the answer. Radial acceleration, this is the answer. Right? Next question. Question is, in circular motion, what are the possible values, 0, positive or negative of the following? Concept applicable. You know, A dot B equal to magnitude of A, magnitude B into cos theta, into cos theta for sine. Sine of A dot B will depend on angle between A and B. A and B. Right? If theta greater than 90 degree, theta less than 90 degree, obtuse, negative, acute, positive, theta 90 degree, 0. We should know regarding the concept. First part, W dot V. V always lie in the plane of the circle. Plane of the circle. And W always perpendicular to the plane of the circle. Plane of the circle. Therefore, W dot V means W perpendicular to V always. Therefore, answer is 0. B. B part is V dot alpha. Okay. V and A both lies in the plane of circle. Now, if theta less than 90 degree, that is acute, that is speed is increasing. Sign is positive. If theta greater than 90 degree, obtuse, speed is decreasing, negative. Right? This may have 0 positive or negative sign. C part. C part is W dot alpha. Alpha. W dot alpha is omega dot. Omega dot alpha. In this case, theta may be 0, parallel, or theta may be 180 degree, anti-parallel. If parallel, positive, anti-parallel, negative, and 4. Uniform circular motion. For uniform circular motion, alpha equal to 0. It may have 0, positive, or negative value. Right? Now, I would like to request, if you are new to my YouTube channel, CET Shift Learn, CET Shift Learn, please like and subscribe to my channel and press bell icon to receive updates on concept killing videos. Thank you.